We're totally surrounded by smart devices, right? But have you ever stopped to wonder how we actually talk to the tiny little brains inside them? Well, in this explainer, we're going to break down the secret language of microchips.
I mean, really think about it for a second. You push a button, and this little box just does it. It perfectly counts down 30 seconds. It's not magic, of course, but it is a pretty wild conversation that's happening on a level we can't even see.
See, at the heart of it all, there's a tiny computer, a microcontroller, that only understands a very, very limited and super precise set of words. If you want it to do anything, you've got to speak its language.
And that language, it's called an instruction set. The best way to picture it is like a dictionary for the processor. It's a really, really small dictionary, but every single word in it has a precise, unchangeable meaning. Okay, here's the perfect analogy. Imagine our microcontroller is a chef, but this chef is, well, they're hyperliteral. They can't improvise at all. They can only do the exact basic actions listed in their cookbook, and that cookbook is the instruction set. Things like chop, stir, mix, heat. That's pretty much it.
So to make this a little more real, let's stop talking about imaginary chefs for a second. We're going to look at the actual cookbook for a real-world, totally classic chip, the 8051 microcontroller.
And listen, this isn't just some random chip I picked. The 8051 is a cornerstone of electronics education. It's taught in engineering programs all over the world, like the one at the Maharaja Institute of Technology in Mysore. It's basically where you start, the ABCs of microcontrollers.
So, let's get back to our chef. They're ready to cook. The recipe, our program, says add sugar. But where's the sugar? Is it right there in the recipe? Is it in a special bowl? Is it tucked away in the pantry? The very first step is always finding the ingredients. In the world of microchips, this whole process of finding the ingredients has a name. It's called the addressing mode. It's just the processor's method for finding the exact piece of data it needs for whatever instruction it's working on.
Let's break these modes down with our chef. First up, you have immediate mode. That's when the recipe says, use 2 cups of sugar. The data, 2 cups, is right there in the instruction. Super simple. Then you've got register mode. This is like saying, use the sugar from the bowl labeled A. The data is in a special, super quick access spot right on the counter. And finally, there's memory mode. This is when the chef has to go to the pantry, 3rd shelf, and get the sugar. The processor has to go to a specific address to get what it needs.
Okay, so our chef can find all the ingredients. Now, what can they actually do with them? Let's look at the basic verbs, the actions, in the 8051's cookbook.
Right, the recipe says take the sugar from bowl A and the flour from the pantry. What's the next step? This is where the core actions, the really fundamental instructions, come into play.
So what's really amazing is that everything the 8051 can possibly do boils down to just 5 simple types of actions. Data transfer is just moving ingredients around. Arithmetic is just calculating, adding or subtracting. Logical is basically comparing 2 things. Branching is making a decision, like if this, then that. And bit manipulation, that's just making tiny, super precise tweaks to an ingredient.
All right, so we've got our ingredients, and we know our basic actions. Let's finally put it all together. How do we get from these really simple steps to, say, your microwave heating up your lunch for exactly 30 seconds?
This is the key insight right here. Every single complex thing a device does is actually built from a huge number of these tiny, almost ridiculously simple commands.
It's like a recipe that just says, first, move this number from the pantry to the counter. Then, add it to the number already in the bowl. Next, check if the answer is 0. And finally, if it is, jump to a totally different part of the recipe. That's the entire logic, right there.
But here's the magic. When you execute thousands or even millions of these simple instructions every single second, that's how you get a microwave that can count down time, or a coffee maker that knows to start on a schedule. It is all just mind-blowing complexity, born from breathtaking simplicity.
So, the next time you use any device, just take a second. Don't just see a button. Try to picture that hyperliteral chef inside, just following a recipe, one simple instruction at a time, millions of times a second. It kind of makes you wonder, doesn't it? What invisible conversations are happening all around you right at this very moment.